morning, Ethan. Sorry, I was moving papers around. I didn't notice that the time had started. It like counts down, and I just wasn't paying attention. All right. So we're going to take notes on 4-4 today. You'll like this. Well, I think you like every section, but definition of an isosceles triangle is a triangle. Oops. With at least two congruent sides. So that or that. So that's absolutely fine. If it's equilateral, that's at least two. So I'm going to actually erase this. So we're going to get some vocabulary to go with it. The two sides that are congruent, we call those legs. This is the base. That's the side that's not the legs. These two angles at the end of the base, we call those base angles. And we call this angle up here the vertex angle. Now, if it's an equilateral triangle, you could call any two sides the legs and any side the base. But, you know, like we're going to figure out how to find the base angles and the vertex angles. You already know if it's equilateral, which is also isosceles, you already know everything's 60 degrees. So I'm just going to make sure that, like, what if I turned it and said that these were the two legs? So let's say these are the legs. Then this side is your base. These are your base angles. Actually, I should put arrows right there. And this would be your vertex angle. Okay. Because I know that you don't do this, but I think a lot of kids when they're young assume that it has to sit on the base, and that is absolutely not the case. All right, so here's the first theorem that we're going to prove. If two sides of a triangle are congruent, then the angles opposite those sides are also congruent. Okay, so we're going to take everything in this theorem and put it in our hypothesis. The conclusion will be what we're trying to prove. So we're going to take a triangle. Say we take triangle ABC. If two sides of that triangle are congruent, so we're calling AB and AC the two congruent sides, and we draw in this segment AD that bisects angle BAC. Now that was not in the, all it said in here was if two sides of a triangle are congruent. That took care of this part. We're putting this in so that we can actually prove the conclusion. Okay, so took care of that, marked it up. If that segment bisects that top angle, then, which would be the vertex angle, then we know this is congruent to this, and we'll go ahead and say that. So we know that angle BAD is congruent to angle CAD because that is the definition of an angle bisector. All right. We also know that side right there is congruent to itself. By the reflexive property of congruence. All right. So let's see what we've got. Look at those two triangles. This one over here on the left. And this one over here on the right. Can you say those are congruent triangles? Well, of course we can, because it's side angle side. So I'm going to put the triangle BAD. Match up my corresponding parts. That's congruent to triangle CAD. That C doesn't look like a C. Okay, because of side angle side congruency. And if that's, here, let's see what we're trying to prove. Then the angles opposite those sides. So we're talking about this angle and this angle. Angle B and angle C. They are congruent because they sit in the same spot in their corresponding parts of those two congruent triangles. So we know that these are congruent to this. Oh, I said these are congruent to this. Oh my gosh, this is congruent to this. So corresponding parts of congruent triangles are congruent. All right, now this theorem right here shows up so often in a proof. We're just going to draw a picture of it when we want to use it as a reason. So we're going to put, okay, if you have a triangle with two congruent sides, that implies that the angles across from it are congruent. So this is much easier to put in a proof than it is to write that theorem every time. And it says the same thing, and that's just kind of, that's handy. All right, there's a corollary that goes with that. An equilateral triangle is also equiangular. So remember, this is, if you got two sides of a triangle are congruent, then the angles across from those two sides are congruent. But in an equilateral triangle, you have three sides. And so it's like you pick any two sides you want. Say I pick these two sides, then I would know that this angle right here is congruent to that angle right there. And now we have all of them being the same size, which in the next corollary that an equiangular triangle has three 60-degree angles, because you've already shown in the last corollary that they're all congruent, and therefore then we already know there's 180 degrees as the sum of the interior angles of a triangle. Then each one of them has to be 60 degrees. Okay? And I think we've talked about corollary. A corollary is just something that's so closely correlated to a theorem that it's not a new theorem, but it's based on the theorem we just did. Like, those easily and readily appear because of that theorem. Okay. Now, this is vocabulary. The altitude of a triangle is the perpendicular segment from a vertex to the line contained in the opposite side. Okay, so let's say you draw just some random triangle. The altitude from this vertex up here straight down would sit there. Okay, if you took an obtuse triangle this way and you use this as your vertex, then we can extend that, drop it right there. That's your altitude. Okay, or it might be, well, ooh, is this the chapter? I'm just looking over here. This is the chapter. We're going to introduce all these terms. If you take all the altitudes, like say you draw this one in, and this one in, and this one in, then the altitudes of a triangle, they all intersect at one point, and we call that point the orthocenter. Okay. Then there's medians of triangles. So it's a segment from a vertex to the midpoint of the opposite side. So you take just some random triangle, you take a vertex, you find the midpoint of the opposite side, and you draw in a segment. That is called a median. And if you take a triangle and you draw all three medians, find the midpoint of that side. We're going to find the midpoint of this. I'll pretend like that's all the same point, because it is. That point is called the centroid. Okay, so this point right here, centroid. This point right here, orthocenter. Okay, if we have an angle bisector, a ray that divides the angle into two. Oh, sorry, that's the definition. I was about to say, I'm going to write down a theorem. An angle bisector is a ray that divides the angle into two congruent angles. So, which you already know what an angle bisector is, but when you look at it in a triangle, say you draw a ray in that cuts that in half, then that ray is your angle bisector. So, should we highlight it maybe? That's your angle bisector. All right, if you draw all of those, so you draw this angle bisector, and this angle bisector, and this angle bisector. All three of those points, all three of those rays will intersect at the same point, and we call that an incenter. So that point in red, that point right there is the incenter. And then a perpendicular bisector in a triangle, which is just a line or array or say whatever that's perpendicular to a segment at its midpoint. Because you got to do two things. You have to find the midpoint, so it's got to be a bisector, and it has to be perpendicular. Let's do these in a different color so you can see it. So that, ooh, not quite. That would be a perpendicular bisector. We come back, we find the midpoint over here. This would be a perpendicular bisector. We find the midpoint over here. And this would be a perpendicular bisector. And they all cross at one point. And that point is called the circumcenter. Right there. And it does not have to be inside the triangle. Like, it can totally be on the outside of the triangle. Okay. So, I'm trying to think, did we ever prove those? I don't think we ever did in this class, because that's a hard proof. We didn't do constructions either. I used to do constructions at Fort Payne, and it was super, super cool. And I should probably teach you how to do all these constructions. But when we do it, I need you to sit back here at the table so that you're not letting anybody else see that I'm giving you a compass. Like, it used to not be a big deal. Like, all the kids bought their own compasses, and we did the safety compasses, because the safety compasses are crap. Like, that's not a good compass. You buy a Circle Master compass. Circle Master compass is the greatest compass that ever was. And I've got several of them back here that I could let you use. But for the constructions, yeah, I need to teach you. I need to go back and find my notes for that. Actually, I don't even know if I still have notes for that, because that was back at Fort Payne, and I didn't really keep up with anything electronically back then. I usually hand printed all my notes. It was so bad. But yeah, you would enjoy the constructions. That's going to have to come on a day where I can actually be back here with you a good bit. So it'd have to be a work day for the other kids. Hang on, I got to write myself a note about this, because you would like doing these constructions. And I can show you how to make all these shapes, and you can see that they actually do cross at the same point, which is pretty cool. Hang on. So, get constructions ready for Ethan. We used to even have a construction test at Fort Payne High School in honors geometry when I taught it, and the kids loved it. It was so cool. It's just the funnest thing, but it's kind of frowned upon to teach that now, because everybody's afraid that a kid will stab somebody with a compass. I can tell you this: 3 of these are super important. I have yet to figure out. There has to be one. I have yet to figure out the purpose of the orthocenter, other than the fact that, it's just when you draw in all the altitudes, that's where they cross. I'm sure there is something where it's useful. I've just never seen it. So, but these are super cool. A centroid is a balance point. So, like that point right there, if you have some sort of rigid surface that you make a triangle out of and you find its median, you could balance that triangle on the tip of a pin, and it would stay perfectly balanced. So that's pretty cool. The end center is the center of, hang on, let me think about this. I haven't done this in a while. Yes, it's the center of an inscribed circle. And a circumcenter, you don't know what inscribed and circumscribed is. That's coming up later. It's the center of a circumscribed circle. So an inscribed circle means you draw a circle on the inside of the triangle, and so it's tangent to each side. So and then a circumscribed is when you use like it goes around the triangle, and all three vertices of the triangle sit on it. So those actually have uses, and I think, hang on, let me look through these notes. I don't think we do it here. We don't. We were just introducing vocabulary here. But I'm pretty sure we talked about it later. But at the same time, maybe we didn't. Because this is one of the few things that people just kind of let go in geometry because it takes so long to get good at it. But I cannot for the life of me remember if we spent a lot of time on that or not. If we did, I don't know. I really don't remember. We'll find out as we go along. Okay. But, so in an isosceles triangle, the perpendicular bisector from the vertex angle is also the, okay, so if we have an isosceles, here's our two legs. I know that those are the legs because they told me I need a perpendicular bisector from the vertex. And this thing's drawn. It only shows one added segment that could possibly be a perpendicular bisector. So we're going to mark this up. We know this angle would be congruent to this angle. We know this is going to be perpendicular. And so if I'm looking at that perpendicular bisector, so I'm looking at this piece right here, okay, then I've got those two triangles are congruent by side angle side. Or I guess technically we could go angle side angle, but you go with whatever you hit first. So I think I'd go, actually, probably if we're going with the one I hit first, it's going to be angle, angle, side, right there. Okay, so that would make these congruent, which makes these congruent, which makes those congruent, which we already knew because they're the angles across from each other. But if you look at that then, that one segment that's drawn in, a median goes from a vertex to the midpoint of the opposite side. Well, that does that. So it's also a median. And it's also an altitude because it comes from a vertex and hits the other side at a right angle. And it's also an angle bisector because we already said it's a perpendicular bisector. So, oh, actually, you know what? Hey, hold the phone. I'm going to go back and reorder that because I just said something that wasn't true. I'm totally not thinking. Okay, we're going to start over again. You already have it written down. It's written down correctly. So a perpendicular bisector. So that means this cuts this in half. We know it's isosceles, so those are my two legs. This has to be a right angle. It did not mean that that top angle got cut in half. And I hope that you were looking at me funny when I just said that because a perpendicular bisector has nothing to do with an angle. It is just, I'm going to bisect a side or a segment and be perpendicular at the same time. So let's see. Oh, now the reason those two triangles are congruent is because of hypotenuse leg. So yeah, ignore what I was saying a minute ago because I made an assumption that it absolutely is not true. But because they're congruent by hypotenuse leg, and that's congruent to itself, these are corresponding parts of congruent triangles. We can mark it all up. Now it's a median, which it was a minute ago, like when I first started, because it's a segment that went from a vertex to the midpoint of the opposite side. But it's also an altitude. Well, no, it was an altitude a minute ago too. Because it comes from that vertex, it hits the opposite side at a right angle. But this is the one it wasn't until I could prove the two triangles congruent. It's also an angle bisector of that triangle. Okay. And then there's a corollary that goes along with all this. So we're going to prove it. The bisector of a vertex angle is perpendicular to the base at its midpoint. So if we start out, we say we've got an isosceles triangle. So let's do this one thing at a time. So triangle ABC is isosceles. Oop, not counting, Gwen. That's because it's given. All right, so we got that. That's going to make AB congruent to CB, or however you want to say it. So let's come from the vertex. BA is congruent to BC, because that's the definition of an isosceles triangle. All right, the next thing they tell you is that BX bisects angle ABC, which means this angle is congruent to this angle. Now, did you notice how I offset those? Like I didn't, like where it hits, come back. Where that arc hits this segment is not the same place as the other one. The reason I do that is because this drives me crazy. When people do like, okay, where is it? That, and then they'll come from it. Like sometimes you can't tell if somebody's trying to mark the entire angle or the two pieces. So I always try to offset them so that there's no confusion there. Okay. But BX bisects angle ABC. That's the other given. Again, you could put all the givens all in the same step. I just like to split them. And that means that angle ABX is congruent. Why'd I put triangle? Don't know. Angle CBX. Because of the definition of an angle bisector. Okay, so what we're trying to prove is that BX is the perpendicular bisector of AC. So we've got to prove the perpendicular part, we've got to prove the bisector part. Probably we're going to want to get there with two congruent triangles. So I'm going to just go ahead and throw in that side being congruent to itself. Because that's the reflexive property. Okay, now I can say that triangle ABX is congruent to triangle CBX because of side angle side. Let's make sure there's one of the sides, there's the angle, there's the other side. Yep, I'm good. And now we got to get the perpendicular and the bisector part. Okay, so what do we want to do next? Let's do the bisector part. I know that this is congruent to this. So I know that AX is congruent AX, CX. Because corresponding parts of congruent triangles are congruent. Now, because AX is congruent to CX, that means X is the midpoint of AC, because that's the definition of a midpoint. Okay. What do I want to do next? Now this one, angle B, oh no, I'm trying to get, that's basically got me the bisector part. The perpendicular part, I know that this angle is congruent to this angle. So angle BXA is congruent to angle BXC because of corresponding parts, so congruent triangles are congruent. And then let's just go ahead then. That means that, let's use an old theorem, that BX is perpendicular to AC because if two lines, we haven't done this theorem in a while, if two lines form congruent adjacent angles, those lines, oops, I was going to put the end in there. Then those lines are perpendicular. So now I can come back and take the congruent part out and put in the perpendicular part. And then let's see if we've got what we need. For it to be a perpendicular bisector, a segment has to be perpendicular to the other segment and it has to go through the midpoint. I said it went through the midpoint right there. I said it's perpendicular right there. I'm good to go. So BX, my pen is struggling this morning. Maybe it's me struggling. That's probably, is the perpendicular bisector of AC, because that is the definition of a perpendicular bisector. Okay. Man, these notes are long too. How much more we got here? Whew. I should have gotten here earlier. Okay. Next one, next theorem. If two angles of a triangle are congruent, then the sides opposite those angles are also congruent. Okay. So this one, they went ahead and put the givens in there for you. So we've got our triangle. They're saying there's two angles that are congruent to each other. We drew in AD that bisects angle BAC. Now, if it bisects angle BAC, that means that this angle is congruent to this angle. So let's go ahead and start there. Angle BAD is congruent to angle CAD, because that's the definition of an angle bisector. And we drew that in to get to where we want to go. So because you put it in the diagram and you told people you're putting it in there, we're good to go. So for this part, we've got an angle. For this part, we got another angle. We've got a side congruent right there. So AD is congruent to itself. Ooh, that's triangle, not A. By the reflexive property. Okay, there's our side. Now we can say that triangle BAD is congruent to triangle CAD because of angle-side congruency. And what we're trying to prove, the sides opposite those angles. So this side and this side. We're trying to prove that AB is congruent to AC. And we just did 1, 2, 1, 2, because corresponding parts of congruent triangles are congruent. And instead of writing this theorem every time we want to use it, we're going to do a picture for it too, just because it's so much easier. So if you know this, that implies that you know that. So I'm going to use that in a lot of proofs. What time we got? It's 6:21. Whew, I would love to be done by 6:30. I just don't see it happening. Okay, corollary. An equilateral triangle, or sorry, an equiangular triangle is also equilateral for that very reason. So if you know that all these are the same size angles, then this is congruent to this because of the theorem we just proved. But if you'd been looking at like these two, then that would have been congruent to this. So that makes them all the same length. So equiangular triangles are equilateral triangles and vice versa. All right, this page will go quick. I know this is an equiangular triangle. Those are all 60 degrees. So I know 5y is 60, which means y is 12. Okay, so we got that part. I know equiangular triangles are always equilateral, so I know that 5x minus 6 is equal to 3x plus 2. So 2x is equal to 8, x is equal to 4. Actually, I'm going to do this. I kind of like the pen. Like, here's what's happening. Is what's getting me frustrated. Is the pen has a little part where if you tap it 3 times, it'll swap back and forth. Or is it 3 times or 2 times? Maybe it's 2 times. Anyway, when you tap it, it swaps back and forth from the pen to the eraser. But for some reason, the tapping thing's not very responsive today. Okay, so we got this. All right, and probably you're going to want to pause this and try these yourself because I know you enjoy that. So if these two sides are congruent, the angles across from them are congruent. So I know that x has to be 60. If these are, no, it's not 60. I'm not looking at it right. Slow down, Gwen. Okay, 66. And then if you've got 66 and 66, I know that 2 of those added to y has to make 180. So how much is that? 132. So 130, 50, 48. Yeah. we got those two. Okay, so looks like we've got 3 equilateral triangles. I know that every single one of those angles, 60 degrees. I don't know if I need that. Oh, I do. So y, 60, x, let's figure that out. Okay, if this length's 40, so's all those, so's all these, so's all these. That means that's 40 also. So 4x has to be 40, x has to be 10. Oh, and just if you're wondering, sometimes I get lazy and my x's don't go, and I always come back and do this because that, well, it's got a little curve to it. That's a lambda. And I don't want them to ever get confused for a lambda. Let's see what's going on here. I know, I'm going to change colors. I'm getting tired of this one. I know that this angle is congruent to this. So this is also x plus 30 degrees. Ooh, here's an exterior angle of a triangle. I know that that exterior angle's measure is the sum of the measures of the 2 interiors. And so I'm adding up the same thing twice, so I can just double it. So 5x plus 12 is 2x plus 60. That means 3x is what, 48? X is 16. Okay. This one, all right, if these two are congruent, then these two have, oh, they're not, duh. Why am I being an idiot? If these two are congruent, I gotta drink more coffee. They're not congruent. One is 42 and one is 41. I'm not sure what I'm thinking. Okay, so let's do this first. 56 and 62, how much do we have so far? 118? So 120 to 180, that's 60. So this is 62 degrees up here. Okay, so if that angle is congruent to this angle, then the sides across from those are congruent, so this has to be 42. That makes more sense than what I was trying to stupidly say a second ago. All right, I know these are congruent sides, so 2x minus 4 has to be the same thing as x plus 5. So x is 9. All right, 625. Oh, well, how many more pages I got? 1, 2. I don't think I can do it in 5 minutes. We'll see. Okay, let's see what's happening here. All right, if I look at the big triangle, it's isosceles. And so the 2 angles across from those congruent sides have to be congruent angles. So I know that's a 43-degree angle. Up here, if I'm cutting this angle in half, then that means I've just created, so that's an angle bisector, which means it's going to be a perpendicular bisector. Okay, so if this, so just looking at the left side, there's 43 degrees. That leaves me what, 47 degrees up here to make the 90 degrees. And also, when you drop a perpendicular in an isosceles triangle, you cut the base in half. So this has got to be 5. Do I have it all? Nope. This is obviously 10. So x has to be 47. Y's got to be 10. And z's got to be 5. Yep. Okay. This one, all right. These 2 angles have to be congruent because you got an isosceles triangle. Now, if this angle up here is 60 degrees, then these both have to be 60 degrees. So we got that part. Okay. If 50 and 50, you got 100 so far, that makes that 80 degrees. So x and z, so x, y, and z. X and z both have to be 60. Y has to be 80. Okay. Another proof. Okay. Let's see what we got. SR. Ooh. So all this is congruent to all that. And usually that's the way that's done. Like you'll just make a little indicator like, ooh, this is congruent to this. So SR is congruent to ST. That's given. Okay, now let's see what I'm trying to figure out in the first place. MP is congruent to MQ. All right, now if that's what I'm trying to figure, then I'm probably going to end up looking at those 2 triangles. Okay, because you're trying to prove this side congruent to this side. Now we got some work to do to get there. What if we just thought about this as one big isosceles triangle? Because we know that this is congruent to this. Okay, because we know that, we know this angle is congruent to this angle because those are the angles across from those congruent sides in that triangle. So I'm going to go ahead and write that. I know that angle R is congruent to angle T because when I know this, I know that. So I'll mark that up right there. Okay. So I got that out of the way. What else do we know? We know that MP is perpendicular to RS. Okay, so MP is perpendicular to RS. So I know that's a right angle. So I know the angle RPM is a right angle because that's the definition of a perpendicular line. Okay. I also know that MQ is perpendicular to ST. So that makes that a right angle. Got all my givens. That means angle MQT is a right angle because that is also the definition of perpendicular lines. And again, because I split my givens, that's 6 steps when it could have been, I could have put both of those in one step, both of these in one step, and that, so it could have been 4 steps, but that's okay, I don't care. whatever floats your boat, Ethan, as long as it's right. All right, I don't know why I changed to red, that seems a little odd, but I just did it. Okay, what else do we know? Oh, I know, angle RPM is congruent to angle MQT because all right angles are congruent. Okay. Oh, there's another given. Haven't even talked about that one yet. Yeah, I was about to say I don't have enough to go on, but I was like, oh, there's another. M's the midpoint of RT. Okay, so if M is the midpoint of RT, that means that this side's congruent to this side. So RM is congruent to TM because that's the definition of the midpoint. Okay, all right, now let me look at those triangles. Angle, angle, side, angle, angle, side. So right angle, angle 1, side 2, right angle, angle 1, side 2. Those two triangles are congruent now. So triangle PRM is congruent to, what did I start? The right angle? Q, and then I want the angle. There's that order. Because of angle, angle, side congruency. All right, make sure I had everything. So the right angle was one of them. That was one of my angles. R, that was the other angle. And then the side was this one, yes. So I've got all my angle, angle, side in there. And then now I can say that MP is congruent. So MP is congruent to MQ because corresponding parts of congruent triangles are congruent. Well, one more. Nah, 632. I didn't make it. I was like, I didn't think I would. Ooh, this got cut off when this printed. This is an E up here. Okay. I don't know if you can see. I don't know if you can see that on yours or not, but if you can't, that's an E. Oh, shoot. And this is one of those. The new version of Word was not real nice to me. I need to probably go back and fix that. Hang on a second. If I don't do it right now, I'm going to forget. So here's the notes. Right, let me just. I forgot. Did I use equation editor to do this, or did I do? We had this program. I don't know what it is. I probably need to just retype it. Yes, convert it. Oh, there it is. Okay, now I got it. Which means I need to resave this. Oh, hang on. Before I do that, do we have anything in the answers that are going to be messed up? No, those all look good. Okay. File. I know you can't see what I'm doing. You're like, why do you do this, Miss Brand? This is ridiculous. Resaving it, the PDF that'll go on Schoology. We're that fixed. And let me just go ahead and I'll reprint this so that your notes will actually be right. And you'll be like, why are you doing all this? Because I don't want to send it to OneNote. I want to send it to my printer. And I want to print it on both sides for you. All right. We're in business now. Okay, so number one, what we got? So let's do our givens. WR is parallel to ST. Okay, so WR is parallel to ST. Okay. What do we want to do? Let's see what we're trying to prove. Triangle SRT is isosceles. So we need to prove that this side and this side are congruent. Probably those two sides. It could be two other sides, but my guess is going to be those two. So how about we just go ahead and say this. If these are parallel lines, and here's my transversal, then I know right now that angle 1 is congruent to angle S. Because parallel lines imply congruent, alternate, interior angles. Okay, so let's get this all out of the way. Okay, so I took care of that given. I've got a step after that. All right, let's see what we're going to do now. There's another given. WR bisects angle SRE. Ooh, I made that a little, had my hand coming up the other side. I couldn't see where I was lined up. All right, so WR bisects angle SRE, which is given. All right, so WR bisects angle SRE. Okay, so that means that angle 1 is congruent to angle 2 because of the definition of an angle bisect. I'm tapping. Why won't you turn to an eraser? Of angle bisector. Okay. Ooh, let's do the transitive property. That means angle 2 is congruent. Do I want to say that yet? No, probably not yet. Okay. Let's go back to our parallel lines again then. I don't know why I didn't just get this the first time around. So angle 2 has to be congruent to angle T because parallel lines give you congruent corresponding angles. Okay. But we still haven't said that these are congruent to each other. But let's see. Angle 1's congruent to S. 1's congruent to S, 1's congruent to 2, and 2's congruent to T. Probably. Can I say that all in one transitive property? I probably shouldn't. I think I want to. I think I want to just say angle S is congruent to angle T, but I think I probably need to do it in steps. I think I need to say that angle I already said that. Can I put it all in one? I'm just gonna. 1's congruent to S, 1's congruent to 2, 2's congruent to T. That means S is congruent to T. And I probably need to break that up into two different transitive properties. But I think we're to the point in the year now where you totally understand what the transitive property is. And I know the transitive property is if A is congruent to B and B is congruent to C, then A is congruent to C. Like, you're only supposed to be dealing with 2 different congruency statements and coming up with a third. I dealt with 4. Or I dealt with 3 and then came up with a 4th. Technically, I should probably do that in 2 steps. And I'm just not gonna because I don't feel like it. Okay. So now I know that this is congruent to this. I've proven that. And if that's true, then these are congruent because they're the sides across from that angle. So I know that SR is congruent to TR because I knew this and it implied that. And then if that's the case, then that's an isosceles triangle. So triangle SRT is isosceles because that's the definition of an isosceles triangle, is that I have at least 2 congruent sides in it. Okay, so you're gonna do these out of the book. So it's all written exercises. The answers are right here, but the solutions will be posted online. And I'm probably not gonna post anything until planning period because it's already 6:39 and I'm not ready for school yet. I don't know if I told you this or not. I may have. I've got all my college, not all my college girlfriends, but a big chunk of my college girlfriends are going to be at my house this weekend. So I've been working, I was going to come down here and work yesterday, but I've just got too much house cleaning and stuff to do because I want them to think that I'm not a slob, and I kind of am. So there's a lot, there's a lot to get done. So that's why I didn't come do that this weekend, and I don't feel bad about it. Also, I think I just traded out the good one. Yeah, I took out the bad copy of the notes and put it in the good one. So you're all set there. You hopefully did really well in that little short quiz. I can grade that and have it done, have it back for you by tomorrow. So let's see what's going on. You're going to do the book work, and then there's a proofs worksheet that you're also going to do. I think you got enough time to do all that. If not, don't worry about it. We'll, like always, whatever you don't finish, we'll push to tomorrow. And I promise I'm going to start making notes for the counting book, but it's, like I said, it's going to have to wait until after this week's over. And did I tell you I got hired by A+ to proofread all their materials? Well, for Accelerated 8th and regular 8th. And I'm hoping that I do a really good job and they'll let me proofread everything because it just drives me nuts when there's mistakes and stuff, even though I do it myself all the time. All right, get to work.